Hi everyone, this is a second tutorial on Cadence in terms of simulation. So basically in the previous tutorial we created a library and we have the schematic and the symbol. So in this tutorial it is going to tell us how to simulate using Cadence. So in order to do that, we will first require a test bench. So we're going to build one test bench right now. So let's go on. So File, New, Cell View. So there's the thing. So at times Cadence hides up windows in the behind. So just watch out for that. So it was hiding this window behind. So you will get a window asking for a new file. So let me rename this as test bench. The view is schematic and it opens in schematic L. Say okay. So this again popped up our schematic L editor window, and basically I'm going to build my test bench in this. So the quickest way is I'm pressing bind key I for adding an instance. So browse. So typically we did was have the 90 nanometer library before, but that's not the case. Here we want to simulate our own design. So if you go to our library here, which we created, and there's our inverter tutorial and the symbol view whichever we created, and basically that's gonna come over here. So just place the inverter and escape key to end the command. Now there are a few navigation tips I'd like to give in Cadence. So when you're doing a big design, you tend to zoom in or zoom out to the design. So we use these nice little options to zoom in, or commands to zoom out, or you could even fit to the whole screen here. So the bind keys here are given here. So you can go to view, zoom in, or the parenthesis keys, which can help you zoom in or zoom out, or zoom to area, Z, or zoom to fit, will fit to the whole design. So just gonna give a quick demo. So I'm using the parenthesis key to zoom in or zoom out the design, and I'm just pressing the F key now to fit the screen. So these are pretty handy when you're doing schematics. So basically I'm gonna try to find the DC characteristics of the inverter. So I'm gonna do a DC analysis. In order to continue, this inverter needs a power supply. So I'm gonna find a DC source for this. So bind key I. So we're in the wrong library. So we'd go to browse. So in order to find your sources, you could go to the Cadence IC library. Just click on the plus. You would get a drop down and a bunch of different libraries. So the one we're interested in is in the analog library. So just click on the analog library. Since we have the show categories checked, we have Cadence has categorized all the cell views. So we go to sources, independent source, and that gives us a list of sources which are independent, as in they're independent voltage or current sources. So we are interested in VDC, or you could just type the name here, VDC, to get. So if you're more familiar with Cadence, you would rather type it for a quicker access instead of searching. So here's the symbol view, and you could see there's a window that got popped up behind. So you click on that, that gives you the properties of the DC source. So it gives, you can set the DC voltage or apply a AC magnitude on top of that with the phase, etc. So I'm just gonna give 1.2 volts. Say hide, and I could just place it there. Escape. Now it's more common that people try to move around stuff for space, so what you could do is you could just try to move this DC source or any of this. So I would go to edit, move, the bind key is shift M. So if I just click on move, I'm gonna get Cadence gave a command here, point at an object to move, and this is the command it's going to run. So I'm going to click on this DC source to move it, so I could move it anywhere I want. So I'm going to just space it out. Well, there you go. Escape key. And now I need another source here to do a DC sweep for the input. So what I would do is I could still go to create instance and do that whole procedure, or the quickest way of doing it as a tip is you could copy this and put that. So in order to copy, you could go edit, copy, or the bind key is C. So just click on copy. So again, Cadence is pointing out point at an object to copy. So I'm just gonna copy the source. So just go near the source, single click, and drag, so you get a nice source, just the copied version of the original. So I'm just going to place this here, escape key, and now the components are done, but the wiring is not done. So I'd go to wire it quickly, use wire command W, connect them up well, and then this goes to VSS, output, escape. Now I gotta find grounds for these, for my circuit. So I'm gonna go back to instance, press the I, and I'm gonna find that in the analog lib. So let's go to browse, find ground. There seems to be no ground. So what I would do is let's go click on everything. Scroll on top. There you go, you have the ground here. So if you just click on this, you get the symbol view of that, or you could just type ground here, and this is another pop-up window that really doesn't matter, it's just showing you the ground instance. So you could just say hide, and now you could just place your grounds. What you could do is abut this ground directly to this node. It doesn't really matter, so I usually put a wire, so just connect them. So my grounds are connected. Now it's important to check and save your design. So let's see, now since I could connect a load capacitor here for the inverter, or you could leave the node floating, but I would show you both. So if I leave the node floating and do a check and save, it's going to pop up a warning. So let's do that. So check and save, that gave me a warning here. So let's see what the warning is. So it says pin out instance floating output. So it's complaining that the output is floating. So let's add a capacitor as a load. So instance I. So I would take the capacitor from the analog library. So just say browse. So in the cell you could find, if you're a Cadence user, you know what to find, but say for a starter you don't know where it is. So I would go to passives, and there you have it, cap and symbol, and here's the symbol for the cap. And note that you have the pop-up window as it popped up before. So it's going, you can change the value of the capacitance here. So by default it's about a picofarad. It's kind of a bit high for this circuit, but it seems okay. So just say hide. So you can connect to that node, escape, and connect that to ground. Check and save, and you have no warnings. That's good. So your test bench is complete now. So the next step is to invoke the simulator. So I would go to launch, There are a bunch of other cool stuff here, but I'm interested more in the analog design environment, or ADEL. So just click on that. I get another window, which is my main window for the analog design environment. So I will run my simulations here. So basically this window has three sub windows, which says design, variables, analysis, and outputs. We'll be coming closely to that. Before that, let's see one thing. There are nice menu options here. So before you do a simulation, you just have to check on the model library. So you can click on this little icon here, which will bring you to the model library, or you could just go to setup model library. So we click that, the same thing comes up. So now default, it pointed the GPDK90 library file for the Spectre simulator to run. So if this is not there, you gotta find the path in which it's going to be there and point that file. And there's another column here called section, which has a nice drop down. So this basically gives, you can set the corner simulations for the design. So you want a slow corner, you can choose a fast corner or a typical corner or any other corner. So I would just leave it to typical right now, or NN. So just say apply, okay. Note that if you don't have the model library, Spectre is going to throw you an error saying that no model libraries are found. So you need to be careful in setting up the model libraries. So the other way of doing or continuing the simulation is like, you need the design variables are basically there for sweeping. So any variable in the design can get extracted here. So in order to get that, you can say variables copy from cell view. Okay, nothing came up. The reason is there are no variables in your design. So since I'm going to do a DC simulation to find the DC characteristics of the inverter, I'm going to change this to a design variable. Note that once you click here, you have another property editor which you can edit directly, or you could just hit the bind key Q, which will give you the edit property button which we saw before. So you just say, I'm going to rename this to a variable called vsweep. You can name it whatever you want, so just vsweep looks cool. So that got changed to vsweep. Don't forget to check and save your design. So if you don't check and save, the simulator is not aware of the new changes in your circuit, and it doesn't match the netlist, so it's going to give you errors. So this variable has to be reflected in the ADE. The simulator has to know it. So we again do a variable copy from cell view. Aha! And this time you could find the vsweep that's been added here. So this vsweep in the design is getting reflected here. So basically, Cadence, though you're sweeping your variable here, Cadence needs a default value. So in case if the sweep fails, it's going to take this value. So don't forget to mention this value. So I would rather keep it at something like 0.5 volts. Okay, that got reflected now. Basically, you're not finished yet. You need to set up some analysis. So you could use this shortcut key to open analysis, or you could go to analysis and choose. So it's going to pop up the same window. So it's just a shortcut key. So here you could run different analysis. You could run a transient analysis, you can do a DC analysis, an AC analysis, periodic steady state, periodic noise, you could do a S parameter analysis, etc. So basically now I'm just interested in doing a DC sweep, so I click on DC. See a bunch of other options here. So I would say save DC operating point to know the DC biases in the circuit. So it's a quick way of estimating the DC biases in the circuit, like the drain currents in the transistors, the GM of the transistors, and the voltages that are across the transistor. So it's going to do a DC analysis of the complete circuit. And since I'm going to find the inverter characteristics, I need to sweep the design variable. So I'm going to click on sweep variable. So you have a bunch of other options to sweep. So I'm going to click on design variable here. So it's going to ask me for a variable name. So if you don't know, that doesn't really matter. So you could, there's a nice button here called select design variable. So I click that. It's going to give vsweep. It basically gives you the list of variables in the circuit. Since we have only one variable, so it's just vsweep. So we'll just say OK. And it asks you for a sweep range. So I start from 0 to say 1.2 volts, which is my supply voltage. You could do different sweep types. You could do an automatic sweep type where the simulator estimates what and how many steps you want to simulate. Or you could specify it in a linear way. So you could give a step size or number of steps you want to sweep in between the variables. Or you could do a logarithmic kind of step for, you know, how many points you need per decade or number of steps you want totally. So I would just leave it to automatic now, and then make sure that your analysis is enabled. So even if this is not enabled, you're not going to, the simulator is not going to run anything. So make sure it's checked and then say OK, and that's going to reflect here. Although if you don't, let's say you forgot to check this, it really doesn't matter. You could still check it here. So there's a nice checkbox here called enable. So you just click on that. That's going to enable your simulation. So you're still good to go, but nothing's going to work as it's not going to plot anything. So you need to set up your outputs. So if I have to plot anything, I need, say in this case, I'm going to plot my output voltage versus my input voltage. So what I'm going to do is going to outputs to be plotted, select on schematic. In Cadence, basically clicking on the node gives you the current, and clicking on the wire gives you the voltage. I'm going to click on the wire there. Oh, oops, I think that clicked on the node. Very sorry if you just click there. So let's probably zoom in the design and then okay. The reason this is not taking is because the capacitor is too close. So you can hit escape or drag, and that's basically it. Check and save. Here it kind of added the two things, but I could anyway. I'm going to delete that. Can use the delete. Alright. Oops. Cancel. So right click delete. There we go. So you can say outputs to be plotted, select on schematic, and that's the output I'm going to select, and F to Fitbit, and this is the input. So I click this, and you can see that the nets here are highlighted. So this means that these nets are used to analyze or to be plotted. So they're highlighted in different colors. So if you just go back here, it's going to give you the outputs that's going to plot. So you're good to go to run your simulation. So in order to set up this takes a lot of time. So you could save your state by clicking the save state, or you could go session save state. So when you do that, you could just save your session as what state you want to be in. So you just click to directory, change that to directory, and then you could say save. So now your session is saved. So next time you want to load it, you can just load the state. So make sure you're not on the cell view, you're on the directory. So make sure you click on directory where you could find your state. So you can find the simulation state under this library and under the design. So if you have multiple designs, you can have different states. So state 1 is good, and then say OK, and then you're good to go. So this button will netlist and run your design. So it started to do a sweep. This window here shows you how it swept the voltage and what steps. So it's going to start from 0 and go all the way to 1.2 in those steps. Since we set up a automatic sweep, it's going to simulate in its own step of 24 millivolts, but you could specify the steps if you want lower points. So basically here's our output data. We have DC output voltage versus the input voltage, and this is the input voltage we swept from 0 to 1.2, and this is the switching characteristics of the inverter. So the point in which these two intersect is your threshold voltage for the inductor. Sorry, for the inverter. So we have the output sweep versus the input sweep. So this point is giving the switching characteristics of the inverter. So the data here could be marked anywhere you want. So you could say marker, create marker, and you could have a horizontal or a vertical marker if you want to analyze waveforms, or you could have a point marker just pointing to a particular place. So I would just say you can have, there are other options like choose by X, Y, X mode, or you could give the grid locations or the coordinates. The other way to do is you just point your mouse wherever you want and hit the bind key M. That's going to give you a marker there, and you could move this marker, just click on and drag it wherever you want. That's going to give you that. And if you want to compress this waveform, you can just pull this here and move or analyze wherever you want to do. And if you want to change the scale of it, you just come near the scale and do a right click, and you could change all the axis properties, or you want to plot it in log scale. It's up to you. So you could even change the color if you don't like this color. So pretty much it's fine. There you go. Looks much better. Yeah. Or you could split these two waveforms into one if you don't want it together. So these are different options you could do. You can merge the waveforms if you want. So basically this gives you the inverter characteristics. Another thing I would like to show you in this tutorial before we end it is we did save the operating point. So we could go to results, annotate, and DC operating point. So this option is going to give you all the DC characteristics. So I'm just going to click on this, listen and read, say read, and then I think you have to run that again. Let's say annotate DC operating points, listen and read. There you go. So the operating points have been stored here. So it gives you what is the drain current through the two transistors, what is the gate and source voltage, the drain and source voltage, and the GM of the device. So this basically is helpful in quickly estimating the DC characteristics of the inverter. So that's a quick tutorial on how to run simulations in Cadence. Thank you for watching.